Hey y'all, this is OXDF, and today we're doing Advent of Code 2023, Day 17, Clumsy Crucible. Um, Again, lots of story, but we're gonna get a grid of single-digit numbers, and we start in the top left corner, and we got to get to the top bottom right corner, and the goal is to get the path that picks up the minimum amount of heat. So basically, as you move along the path, we're gonna add the number u for each square, and we want the shortest path, the path with the least total number from top left to bottom right. And there's a few little rules. Let's see. So one, we can move at most 3 blocks in a single direction before we have to turn left or right. Um, we can, let's see, what's another one? We can't go straight too long. There's another one in here somewhere that says, where does it say it? We can't go backwards. I don't know, it's in here somewhere. So you can't, if we're going to the right, you can't just turn around and go back left. So when you've moved your 3 spaces in a row, you can't go forward, you can't go backwards, you can only go up or down. And I guess that's basically it. What we're going to do here is going to be kind of like a breadth first search mixed with Dijkstra's algorithm. So basically, we're going to do the same kind of, it's going to look kind of the same structure as usual, but we're going to use a priority queue so that we're always pulling off the lowest one. We'll go into that, I guess. Let's start off by using Genday script here. There's a link to this in my description here in my repo. And basically, it's going to pull my input and give me a stub. Let's also grab the example. Let's also grab example.txt. Let me grab that. Not the one with the arrows in it. Grab that one. We can have that to work with. Sweet. Okay, let's check out our input. I'm not sure exactly, all single digits. All rows seem to be the same length. 141 rows, but yeah. Okay. Cool. So we're going to use a cool library called heapq. Heapq. And what heapq does is it operates on a normal list, but it'll be in a situation where you can always pull off, you can put things into this queue structure and you can always get off the lowest one easily. It's kind of interesting. If I do x equals 1 like this, I can call the import heapq dot heapify on x, and now x is now a heap, and it's not going to be sorted, but it is going to be I'm going to be able to get the lowest one off anytime. So if I did x, let's see, heapq dot heap pop x, it gives me the one. It updates the heap in such a way that I can always get the next lowest one, which is, but it still might not be fully sorted. And that's if I want to push something onto the list. So I can do heapq.heap push, and then we're going to give it the list, and the value will be, what should we pick? 4. And now x will be here, and again, it's not necessarily going to be sorted, but if I ever want to get the lowest value, I can always, it's always going to come off in a sorted way, leaving what's left. So we're going to set it up so that our heat loss is our lowest value, or is our value we're sorting off of. And what that's going to mean is, effectively, we're going to do kind of like our breadth first search, but instead of doing a breadth first where we're just like stepping out in every direction and we might get stuck in big loops, and because of all the complexity to maintain, we're always going to be moving. So we're going to basically check all the spaces we can get to for 1. Then we're going to check all the spaces we can get to for 2, then for 3, then for 4. And that way we know when we get to the end space, it's the lowest way to get there. So the way we're going to do that, let's see. First thing we're going to do, that's a lot of talking, that much typing. We want to, let's initiate, we do need to get integers into our, so far we've been using a lot of these grids, we've just left them as lines. I'm going to go ahead and create a grid here, and I'm going to make it a dictionary so I can just easily look up by tuple. And so what I want to get to is, the key is going to be r, c, and the value is going to be int of val for r, line in enumerate lines, for c, v in enumerate line. think that will do it for, oh, wait, dot strip, because I don't want the new line. So that should give me a nice grid. In fact, let's check it. Python day17 example.txt. I'm not going to go through and check each one of these, but 0, 0 is 2, 0, 1 is 4, 2, 4. So we're looking good. Okay. Now let's set up our walk here. We are going to need some of the same things we've needed before. I'm going to go ahead and save off height because I think it's going to be useful to have, equals len lines width equals len lines dot strip. Oops, not lines. Lines 1 dot strip. Now we can do our search here. We're going to need a queue. We're going to say that, call that, and we're going to put our state in here. We'll have to figure out exactly what our state looks like in a second. We're going to have scene is equal to set. We will do while queue, and then we're going to do some stuff. So what are we going to do? We're going to say heapq dot heap pop on queue to get off our state. And what is our state going to include? Well, we're definitely going to start with the heat. We're going to that's because it's the first value in this tuple. We're going to store in this tuple. That's just what it will sort on, which is perfect. We're going to need RC. We're going to need to know the directions we're going. So we'll need DR, DC. And we're going to need to know how many times in a row our streak, I guess is what I'm going to call it. I guess we'll call it S for simplicity here. And so up here, our queue is going to be, let's put this in. We start with 0 heat. We start in 0, 0. We start not moving in any direction. And we start with a 0 streak. So that will work. Okay, so now we've got our stuff. If we don't want to put our heat into our scene, because that means if we get back with a different value, we come back with a different value. We already know we've accounted, because we know we're doing the priority queue, we're going to be getting it to it lower. So if we've been to the space at all, we don't need to come back again. So we're going to say RC, DR, DC, S in scene, continue. Now, let's also do a bounce. Oh, no, sorry. We'll do a success check too here. So we can say if R equals height minus 1, maybe, yeah, that's okay. And C is equal to width minus 1. Part 1 equals heat. And we will break. Should be, we can get rid of this. We're just going to assume we always hit that. So now we've got to a new spot. We'll scene.add, and we will add RC, DR, DC, S. Now we can do for next DR, next DC in, but we'll just do all the directions. So -1, 0. We're obviously gonna have to handle a bunch of exceptions here where we throw a bunch of these out, but we'll loop over all of them. -1 and 0, 1. So for all the possible directions you can go from a space, we'll say next R equals next DR. I don't know why I put that there. Next C equals C plus next DC. If next R is less than 0, or next R is greater than or equal to height, or next C is less than 0, or next C is greater than or equal to width, continue. And that's because we're off the grid, not valid. We don't need those spaces. We also can't go backwards. So if dr equals, we'll say if next dr equals negative dr and next dc equals negative dc, that's gonna be hit every time basically. Then continue. Can't go backwards. All right. So now what do we do? We can go forward. So if next dr equals dr and next dc equals dc, if streak is less than 3, then heapq.heap push We give it the q, so that's q, and then we're going to give it our tuple, our state. So what's the next heat going to be in this case? It's going to be heat plus grid of next r, next c. Okay, that looks fine. Our next r and c are just going to be next r, next c, next dr, next dc, and our streak will be s plus 1. We went forward. We moved in the same direction, so we increase our streak. Else, continue. Okay, so now we've gotten to this kind of the rest of them. So now at this point, we're not going backwards, we're not going forward, so we're turning. And if we're turning, we're going to just do, we are allowed to turn. So we're going to turn heapq.heap push. We're going to put on our q and our state. Our state is going to be heat plus, it's going to be just like we had here. With that. Next dr, next, those are all the same. It's going to be exactly the same, except we aren't going to, our streak is going to no longer be, where did I paste it? Okay, perfect. Our streak will be 1 because we will have turned, so now we have a different streak. I think that's it. Let's see. We've covered all the cases. Let's go ahead and try this on Python day 17 example.txt. Let's see. Makes it 1 argument. Let's see. We need to make that a tuple. 102. Not bad. Let's give it a try and see what we 817. Awesome. All right, I'm gonna pause and read this. Okay, now it's the same goal, except we have some slightly different rules. We have to move 4 blocks in a direction before we can turn. And we can go at most 10. And I think that's it. So, all right. I hate to do this. This is not, but I don't see a lot of benefit in trying to, I don't see a lot of benefit in trying to just like functionize this thing, because it's just going to be like annoyingly different enough that we're just going to do this, the thing that's kind of cringe, and copy and paste the whole thing here and do some renaming. To make my life a little better, I'm going to comment this out for a second. This, now I can see if I want to change this to Q2, because I want to make sure I get a new Q and a new scene. And now, because that's commented out, I get to see all the things that break. So I can come down here and say Q2, Q2, scene 2, scene 2, Q2, Q2, and then we need to take part 2. Where are we? Part 2. There we go. So now, if we solve this, if we run this again, we should get 817 for part 2. Okay, so we're getting, that's working. So let's change some things here. We have to go at least, okay, so we still can't go off the grid. We still can't go backwards. If the direction is the same and s is less than 10, because we still can't go more than 10, then we're going to add, then that's still going to get added. And so here, instead of just doing an else, we need to do an elif s is greater than or equal to 4, then we can turn. And is that it? Part 2 is not defined. Clearly that's not it. Why would part 2 not be defined? So that means we're not ever getting in here. It means we ran the whole queue and we never reached the end. So let's do this. We will print Q and see what our Q looks like. Q2 and see what our Q looks like. Okay, we never move anywhere. Let's see. Why would that be? Scene 2. I guess we can debug this. I have a video showing how I set up debugging to work with my setup here. Let's see. So, okay, we got 1 off grid. That makes sense because our first space going backwards. Let's see, can't go backwards. Next dr equals next dc. Nope, didn't do that. And s is not greater than, if we can't turn. Why can't we? Oh, because at the beginning we have no dr and d. If you look here, dr and dc are 0, and so we're not going to have. We have to go forward at least 4 spaces, but we don't have a forward because we can turn at the beginning. So what we're going to say here is, or dr equals 0 and dc equals 0. And that should solve that. Whoa, we don't need that print. I don't even know if that's, let's save that, run that again. Get out here. We can also, just for completion's sake, comment this, I think, now. And we get 194. 94 is our example. Sweet. Okay. We could try this other example if we want. $47? $71. Weird. I got 94. Hold on. I'm gonna try this. Let's see what happens here. I didn't really read much about that other example, so I might not be what I'm looking for. Let's just see if I get the answer. I did. Okay. I'm not gonna worry about that other example for now. Not too bad. The trick really is making sure we are always pulling off the lowest step, the lowest heap possible. And so that basically says, like I said at the beginning, this says like, okay, let's check all the places we can get to in 1. Let's check all the places we can get to in 2. Let's check all the places we can get in 84. Let's check all the places we can get in 85. And so that way, when we do get to the end, we're just guaranteed to get there and we don't have to worry about loops and other things. So, cool. Thanks for hanging out with me today. I really appreciate you watching to the end, and I'll be back tomorrow. Talk to you soon. Bye.